Okay, so here's what we're going to do now. If you can look at the next problem. So we're going to start in this order of operations for laws of exponents. So I notice that I see parentheses and I have an exponent outside the parentheses, which tells me I have a power to a power rule. So I'm going to apply that first, and I'm going to do the same thing I've been doing. I'm going to identify all of my bases inside my parentheses so that I don't overlook any base. Now, I notice that my base of 2 is missing an exponent, which means it's really an invisible 1. So now I know what exponent I'm going to use with the power rule when I get ready to take care of that. So again, power rule does not mean we are taking 1 to the power of -3 in my calculator. I'm actually going to be multiplying these. So I'm going to get a 2, and I'm going to multiply my exponents. So 1 times a -3, and I just like to kind of draw an arrow. It's almost like reverse distribution. So 1 times a -3 is going to make that a -3. Okay, my next base is x. And again, I'm going to circle my exponent, and I'm going to multiply that by a -3. So 0 times a -3 is 0. And now I'm going to take care of my next base, which is a y. And I've got 2 times a -3, which is going to be -6. Okay, let's point out a few things. We are not going to deal with zeros and negatives until we have worked through all the order of operations. Just like you wouldn't skip ahead to subtraction or addition if you had to take care of multiplication or division first. Same thing here. We're going to work those once we get down to our final answer, okay? Another thing, if you have a base that is a number and it's inside the parentheses for a power rule, notice when I wrote that 2 down, I also included parentheses around it. You're going to want to make sure to do that, because if you don't, when you go to type this in the calculator, at some point you are going to get the wrong answer. And I don't want you having to remember when you need to use parentheses and when you don't. So it makes it easier if you always use parentheses around a number that is a base in the power rule. And you'll never get the wrong answer in your calculator. All right, we're going to go ahead and bring down the times 2yx to the third part. Okay, so I've done the power rule and I've multiplied, but now I got to check for multiplication so I know if I need to add any exponents. And of course, we see some multiplication right here. So I know that I'm going to have to be adding some exponents here in just a second. And I'm going to go through just like I've been doing and identify all my bases. Once you get good at recognizing your bases, you may not have to do this a lot, okay? But it's just good habit and a good strategy to use until you get used to working through your laws of exponents. Okay, so my first base that I'm going to take care of is an x. Remember, I'm going to come back to those number bases here in a second. And since we are multiplying, I now know that I need to use the operation of addition. So what is 0 plus 3? It's going to give me a 3. And my next base is a y. Okay, so I've got a -6 here. And when I go over here, I notice that there's not an exponent on this y. So what is the exponent going to be? Remember, any invisible exponent is always a 1. So I've got -6 plus 1. That would be -5. Most students who make a mistake are going to think this is a 0. That is not correct. It is a 1, and you should get a -5. All right, now we're going to take care of our number bases. Now remember, if you have a number base and a number exponent, you can actually use your calculator to help you out and get your answer. So here's what we're going to do. We are going to type this in, because again, I'm going to pretend like my x's and y's are not there and that I just have a regular old multiplication problem. So I'm going to type in 2 in parentheses. To make your exponent, you're going to press this button right above the division sign, and that's going to make your cursor become an exponent. -3. Make sure you push the right arrow to move your cursor down, and now I'm going to type in times 2. And I want to see what is that single number answer I'm going to get when I multiply both bases that are numbers. And I'm going to get 25 hundredths. Well, now if you get a decimal answer, you're going to need to do a little bit more math, because I only want you to write fractions or whole numbers. So if you don't know what this decimal is as a fraction, some of them you may recognize, some of them you may not, you can simply hit math, enter, enter to change it to a fraction, and I got the fraction of 1/4. Okay, so again, we're now here. We've done addition. Now we've got to check. I see no quotient. I don't see a big division bar, so I'm going to skip over that law. I don't need to apply it. And now I'm going to check. And now if you can see, once we did the multiplication law, we did not end up with the 0 exponent. So I have no 0 exponents now, so I don't have to apply that law. And now I'm going to check for no negative exponents. Okay, I see I have a negative exponent, which tells me that I need to rearrange my answer. And a negative exponent tells me that I'm going to have division. So what base am I going to be dividing by? Well, the y is what has a negative exponent. So I'm going to put y, and I'm going to change that -5 to a +5. And now I've got to fill in my other two bases. So I'm going to take care of my 1/4 first. So look here, you have a 4 in the denominator. It can't move. It doesn't have a negative exponent. So I want to make sure my final answer, it still ends up in the denominator. So it is going to join the y to the 5th power in the denominator. Make that fraction bar a little bit bigger. Which means that the 1 has to stay in the numerator. So it's going to go in the numerator. And then now I'm going to take care of my base, x to the 3rd power. Well, because its exponent is positive, it's not moving to the denominator, so it is now going to become part of the numerator. And this would be my final answer. Again, you will not see this 1 here on a multiple choice quiz or test. It'll just be x to the 3rd, all divided by 4 times y to the 5th power. All right, let's try another one. All right, we're going to go over here to this example, and now you can see we have 2 power rules that we have to take care of, 2 powers to a power. So we're going to take care of one at a time. So the first thing we're going to do is, again, I always identify my bases, every single one of them. Okay, we're going to take care of this first, and then we'll look over here. So I don't have a number that's a base, so that makes it really easy. So I know I'm going to have x. And if I forget, I can look at PMA to tell me if power to a power rule means I'm going to follow the arrows and I'm going to multiply. So I'm going to get a new exponent of -20. And now I'm going to take care of my next base, y. Again, I'm going to multiply my exponent. So 3 times 4 is 12. I'm going to bring down this multiplication. And if you're okay with this, we're going to go ahead and take care of this power rule here so that these parentheses kind of go away. All right. I'm going to identify my bases. I've got an x, I have a y, and what do you think that negative is telling me? I hope he said that it stands for a -1, and that means that I have a number here. So remember, they're not going to show you the 1, they are going to show you the negative if that 1 is negative. But I'm also missing an exponent, because remember, every base has to have an exponent. Well, that exponent is also a 1. Okay, so now I know what bases I have, and now I know that I'm going to do exactly what I did over here. I'm going to multiply the exponent. So I have a -1, and remember, the number bases that are in parentheses have to stay in parentheses, and then you're going to write the new exponent outside. So 1 times 5 is 5. All right, next base, x. I've got 0 times 5, 0. Next base, y. I've got 5 times 5, 25. Okay, so we've taken care of power to a power, and we've multiplied. Now we need to check for multiplication so we can add. And I see right here we have multiplication. So that tells me we're going to be adding exponents. So you can kind of see everything's been color-coded, but I'll underline anyway. So I've got my bases that are x. I'm just going to kind of go one at a time. And I'm going to add the exponents. So I'm going to still connect just like I've been doing. I'm not going to change any of that. So -20 plus 0 is -20. Next base, y. And I've got 12 and 25. You can see how this gets a little confusing, but if you have color, it really helps separate everything out for you. I've got y. And I'm going to add, because remember, multiply really means we're adding the exponents, and I should get 37. Okay, we've got one more base. And if I had all the x's and y's go away, I would only be left with a -1 in parentheses to the power of 5. So I'm just going to type that in my calculator. So I've got a base of -1 in parentheses, and I'm going to raise that to a power of 5, and I got an answer of -1. So I'm just going to write -1 out here in front, and now I'm going to go through and check. Again, I don't see a fraction bar anywhere to begin with, so no quotient rule will be applied. I don't have any zero exponents now, so I don't have to worry about clearing that up. And then I do have a negative exponent, so I need to take care of that. So remember, negative exponents tell you that you have division, so you've got to write a fraction bar. And now I've got to see which base had the negative exponent. Well, that would be my x. So it's going to now become in the denominator because now I have to divide by x to the 20th power. And now I'm going to fill in the rest. Okay, y to the 37th is going to become part of the numerator because its exponent is positive. So it is not going to be, we're not going to be dividing by y to the 37th power. So it becomes part of the numerator. And now the -1, it also becomes part of the numerator. Now some of you are going to be like, but Miss Love, it's negative. The number base can be negative and still end up in the numerator. If you think about what the exponent is on this 1 now, its exponent is actually a +1. So positive exponents don't move to the denominator, okay? They stay in the numerator. So that's why the -1 is going to stay in the numerator with x to the 37th power. Now remember, on a multiple choice quiz or test, you're not going to see the 1, you're just going to see negative times y to the 37th power. It's going to look like a -y. All right, now let's look at our little bit of challenge problems here at the bottom. So now I'm really mixing in some stuff. Okay, if you see a giant fraction bar in your problem to begin with, that is a clue that you are going to have the quotient rule. So we're going to be looking at the quotient rule now. All right, but first, we still have to follow the order that we were following earlier. So we're going to do PMA, then quotient, 0, and then clear up any negative exponents. Okay, so first, do we have power to a power rule? I see parentheses and an exponent outside. We sure do. So we are going to kind of rewrite some stuff over here. So I'm going to copy my fraction bar down. Okay, power to power rule, which means we are going to multiply. Again, I'm going to identify all my bases first so I know and make sure all my bases have an exponent. And now I'm ready to multiply. Okay, so I'm going to get x to the 0 power because 0 times 3 is 0. And now we're going to have y to the 2nd power times 3. So 2 times 3 is 6. So the numerator is now going to be x to the 0 power times y to the 6th power. Okay, now let's take care of the denominator. Do we have a power rule? No, but I do see multiplication, so we are going to take care of that in the denominator. Okay, so let's identify our bases. I see a 2 here, I see an x here, and then I see a y here and here. Okay, so let's see what happens. All right, let's take care of our first letter base. Our first variable base is x, and I want to make sure all my things have exponents, so I need to add 1s to the 2 and the x. Okay, so I'm going to have x. Okay, if there's just a 1, do I have anything to add it to? No, it's just going to say x to the first. Next base, y. All right, I see 2 and I see a -3. Remember, multiply is really telling me to add, so we are going to add 2 to a -3, which is a -1. And now I've got to pretend like my x's and y's aren't there in the denominator, and I just have 2 to the 1st power. Well, if you're not sure what that is, 2 to the 1st power is just 2, so I'm going to write a 2 here because I don't have anything to multiply with. Okay? All right, so now we have the quotient rule. So now let's look at, because remember we worked power to a power, we multiplied, we had multiplication, so we added. Now we got to look at the quotient rule, okay, which means we're going to subtract. All right, so again, we're going to identify our bases. We got x and x. So here's how this works. It's always top minus bottom, okay? So you're going to take the top, the numerator exponent, and you're going to take away the exponent in the denominator. So we're going to have, I'm going to draw my fraction bar. Okay, and you're always going to write your answer in the numerator, and then we're going to make some adjustments. Okay. All right, so here we go. I've got x. All right, I'm going to type in 0 minus 1. Top minus bottom. I'm going to get negative 1. All right, next base I have y. Okay, top minus bottom. What's the top? Subtract. And then what's the bottom exponent? It is a negative 1. So remember, this is kind of like your slope rule, slope formula, that the subtraction is not the same as the negative on the number. So I see a dash for the subtraction, which is the operation I have to use. And I also see the negative sign for the negative 1 exponent. And I'm going to get y to the 7th power. Okay, now let's look at our base of 2. There is not a number here to divide by 2, so guess where the 2 is going to end up staying? In the denominator. Okay? So here's my final answer. That is the quotient rule. So now I'm going to check, do I have any 0 exponents? Do I have any 0 exponents? No, but do I have any negative exponents? I sure do. Now remember, if you have a negative exponent, you are going to move it to the other part of the fraction. So if it's a negative exponent in the numerator, you need to move it to the denominator. So this base of x is actually going to come down and join the 2 in the denominator. And that negative 1 is going to become a positive 1. And now I have to write my y to the 7th power in my final answer. So it is going to stay in the numerator because its exponent is positive, and then of course the 2 that was in the denominator to begin with never moved from the denominator, so it has to be in the denominator at the end, and that is your final answer. Alright, let's look at the next one. So I'm going to kind of use part of that fraction bar there because I need a little bit of space. So again, we're going to start with power rule. I notice I have power rule right off the bat because I see parentheses and I see an exponent outside the parentheses. So we are going to identify all of our bases. I have x, and this time I have a z here, and I want to make sure all my bases have an exponent, and that 2 is missing a 1. All right, so now I'm going to have a 2, and remember, if we're doing the power rule, what are we really doing with our exponents? We are multiplying, so 1 times 3 is 3. My next exponent is x, and I'm going to multiply 3 times 3, 9, and my next base is z, and I'm going to multiply, so 2 times 3 is 6. So there's my new numerator. And now I'm going to look at my denominator. I don't have a product rule, so I'm going to move to the next rule, which is multiply. And if I'm multiplying, that really tells me I'm adding. Okay, I have multiplication here, so I know that I'm going to identify all my bases. I've got y. I don't have a y over here, but I do see a z, so I'm going to put 3 on there. Okay, so my first base is x, and when we multiply, we're really adding. So what is 3 plus a negative 4? That would be a negative 1. All right, my next base is y. Okay, this is the only exponent for y, so I'm adding basically nothing to it. What's 4 plus nothing? 4. And now I have a base of z. See if I can fit all this on here. And I have 2 bases, so remember when we multiply we add the bases, so 2 plus 3 makes 5. Okay, and now we're going to use the quotient rule because I have a fraction bar. So we are going to go base by base, and which is why I color coded it, and we are going to write all of our answers. Remember, we're going to write them in the numerator. Okay, so I'm just going to draw a placeholder for a fraction bar. The first base that I have that's a letter is x. Okay, and remember guys, you are going to type in the top exponent, 9, subtract, and then you're going to type in the bottom exponent. What bottom exponent do we have on the x? We have a -1. So I should see a dash for subtraction and that negative sign if your denominator exponent is negative. And I'm going to get x to the 10th power. Okay, next base I have is y. Okay, I should have made z a pink one on top, so I'm going to do y. All right, so if I don't have a base of y up here, I can pretend that I do, and its exponent would be 0. So I'm going to do subtraction. Because I don't have a y up here, I'm going to use 0 because there's not an exponent to use, 0, nothing. And I'm going to take away 4. So what is 0 minus 4? It's going to be -4. And I can tell I need to make my fraction bar a little bit bigger. All right, and my next base is z. I'm going to make that pink. And again, we're going to start with the top exponent number, 6 minus 5. That would be a power of 1. All right, and now we have our number. We have our base of 2, and it's going to be to the 3rd power. So I'm going to type that in my calculator. So I'm going to get 2 to the 3rd power, and that's going to give me an 8. And that's going to go in the numerator as well. And again, I've got to make my fraction bar a little bit bigger. Okay, so we don't have anything in the denominator, so we're just going to use a placeholder of 1. And now I'm going to check, do I have any 0 exponents? And the answer is no, I do not. And now I'm going to check for, do I have any bases with a negative exponent? And you can see that the base of y has a negative exponent. So what we're going to have to do is we are going to have to now rewrite our answer so that we can show we need to be dividing by y. Because remember, a negative exponent tells us we're dividing. Okay, so we know that the base of y is going to be in the denominator, and it's going to change to a +4. Should have written that in green. Okay, so now let's look. Our x to the 10th, it has a positive exponent, so it is going to stay x to the 10th. Our z has a positive exponent of 1, so it's going to stay in the numerator as well, but I'm just going to write z. I'm not going to write that exponent of 1 because I want you to now start recognizing that that exponent that I do not write is an invisible 1, and the 8 is going to stay in the numerator as well because it has an invisible exponent of +1. So this would be my final answer that I would look for on a quiz or a test.